Silence yourselves. Today we are talking about, be quiet please. Today we are talking about, well, the objective says Earth's cycles, but it became apparent to me while I was discussing the lab with some of you that that's not what we're talking about. We are talking about that, but we are talking about the cycles that Earth as an object undergoes periodically in outer space. And so I'm going to rename the lesson. The objective is staying the same. The objective still applies, but I want to specify as we write the title. So if someone could please read me the objective, Avery.
Analyze and interpret data for patterns of change in Earth cycles.
Analyze and interpret data relating to, is that what you said? Data
Analyze and interpret data for patterns of change.
From patterns of change in Earth's cycles. Is that right? Is that right?
Mm-hmm. Yes.
Analyze and interpret data from patterns of change in Earth cycles. So we're looking at data of the patterns, the things that repeat, of the way that Earth cycles change. But we are not talking about, although it does kind of apply, we're not really talking about the Earth cycles as in the water cycle and the nitrogen cycle, although some people had ideas for labs like that. We're talking about the temporal, that is the cycles through time, the periods that Earth goes through in outer space. And so I'm going to call this celestial. Ooh, that's a beautiful word. I'm going to spell it right, though. Celestial patterns. How do you spell it? I just spelled it. C-E-L-E-S-T-I-A-L. Celestial mean? Celestial is a fancy word, a poet's word, meaning relating to the celeste. The celeste. Okay. Either Greek or Latin. I don't know which. I should have looked it up because I was thinking about this earlier. But celestial means relating to the heavens. I'm going to do it in blue. I like to think of dark blue as the color of the heavens, and I don't mean necessarily heaven but we use the heavens even in science. We use the heavens to mean like what's going on outside of Earth, somewhere else. You might say outer space. So this relates to outer space. I am going to specify outer space because this is all space, right? Space is what we call the negative principle that is between matter particles, and that's everywhere. But we're talking about outer space. That is the space that legally begins, I think, 60 miles above Earth's surface. So it's outside of Earth. It's off of Earth. It's off of our normal realm of experience. And we're looking at the patterns. I'm not even going to do a little arrow because you know what patterns are. So what are some patterns? What are some cyclical, right? A pattern is something that repeats. You remember from first grade, Trey, when on your little worksheet it would say square, triangle, square. What comes next? Square, triangle, square. Triangle. You can keep going. What if it says circle, star, circle, star, circle, star? Yeah. So that's a pattern, and that means a repeating. I know. Yes, very entertaining. It's a cycle that repeats. Cycle meaning like a circle. It goes round and round, kind of like the water cycle. So these things repeat. So what are some things that repeat about being on planet Earth? What are some things that repeat? Yeah, the day and night cycle. The seasons of the what? What was the rest of that sentence? Seasons of the year. Yeah.
Years. Months.
Okay. I'll put that. Although this one we're gonna asterisk. You know, like when someone gets in the Baseball Hall of Fame and there's an asterisk because they use steroids their whole life. Oops. Sorry, Mickey Mantle, at Mickey Mantle. Baseball lore. Because some people are really worried to find that out about Mickey Mantle from 1999 or whenever that was. But now I have these. Yes, exactly right. Who said that? Ramrock. But here I have a little hyphen because these are what they seem to us to exist as on planet Earth, but we're talking about the celestial, the patterns that cause this in outer space. And so what about, I'd like it if, I think I want to use that one. Oh, is Amelia tall enough? Amelia, can you, if you reach up, can you grab that? Yep, and then just pull it down, and something's gonna give, and it will come down.
Not be tall.
Okay, yeah, that was way easier than I thought it was gonna be. Okay, you shouldn't have done that. You shouldn't have done that. Yeah, that's a dension. So here I have Earth as it exists in outer space. So we're talking about celestial patterns of Earth as it exists in outer space. And so I think I can't see how this is showing up on the video, but is this side of it noticeably lighter from the windows? Like, does that show up? There are windows over there. Okay, so it's noticeably lighter. And so once every 24 hours, the Earth spins like this. I mean, it doesn't. Let me rephrase that. The Earth spins like this, and once every 24 hours, it completes a single spin. And so if you imagine where the sun is shining in the window, the actual sun is shining in the actual window without even any glass to go between it and us because the windows are open because it's a beautiful day. Look, you can see, if we're assuming that sun, the real sun, is the sun in our model too. By the way, what's a model? What science principle of a model? What's a model? Yeah, it's an imperfect representation of how something is in reality. Just like supermodels, we commonly think of as imperfect representations of what we're going to look at if we put those clothes on. And I do mean that. Like, oftentimes we think of supermodels as like a perfect version of a human being, at least in appearance. But they really are an imperfect representation of how their clothes are going to look because they're not going to look like that when you wear them, are they? So anyway, it's an imperfect representation. That's what a model is. And so if we think in our imperfect representation here, what is daytime right now? What part of the planet, give me the name of a city that is experiencing daytime on the planet in this model. Okay, nope, we're not going to do it like this. We're not going to do it like this. Raise your hand if you have an answer. Amelia, what do you think?
Lincoln, Nebraska.
No, totally wrong. Trey. No. You guys know how anything works? Yeah, okay, what about you, Isaiah? Moscow, yeah. If we have the planet like this, Moscow, which is here-ish, I can't actually see because I'm on the other side of it, but somewhere here. Leave a comment if I'm wrong. Don't forget to like, comment, and subscribe because don't forget to click that bell. Actually, don't, because I don't think anything's going to happen. I don't do that. But somewhere, I'm trying to look through it now. Somewhere here is Moscow. So yes, the sun is shining on it, and that is where it is daytime, as we're talking about right now. So where's someone that's experiencing night right now in this model? Right, Crawford, which I'm looking directly at. It's not labeled. I was looking for the label. I actually was. I was like, where's Crawford? Right here. Here's Crawford, not labeled on this map for some reason, is experiencing night. And so what is happening to the Earth celestially? Raise your hand if you know. What is the name of this that is causing it to have a day-night cycle? So I'm not going to accept the word spin. So if that's what you're going to say, put your hand back down.
Shut up! I raised my hand.
God bless you, Chloe. Okay, let's hear it. I'm calling it rotation. Good, so write that down. So this word, that word is rotation. So the day and night cycle on planet Earth is caused by the rotation of Earth about its axis. And actually, I should be holding it by this because the next one we're going to see is a totally different thing. So, no, well, we really probably should talk about that one next. You're right. Let's do them kind of in order of... Let's do them in order of chronological scale. That is, which one happens. So I'm just going to switch the order of these that we talk about them. And why? I just said it. For chronological scale, what does that mean?
In order.
Yeah, in order of the least amount of time for a single cycle, for what we might call the period of a cycle. Remember, a period is a repeating pattern, how long it takes for a single thing to occur. And so we're going in order, in ascending order of period. That is... So capital T is period, increasing order of period. So a day has the shortest period. What's the period of a day?
24 hours.
24 hours.
That's so nice.
Okay, and so then next we're going to do months, what we might call a lunar cycle. The moon, which is referred to in the word lunar. Lunar means referring to the moon. There's some English knowledge for you. Lunar means referring to the moon. A lunar cycle is called a month. And so for that, I'm going to need the help of... something that... Yeah, I could just drop it. Again.
Don't drop it again.
I'm gonna move this though because it's more breakable and not. Well, it's less breakable than the dinosaur, but it's not anywhere near as fixable as the dinosaur. So I'm gonna real quick put this up here.
Oh my gosh. This is gonna be a wonderful video.
Yeah. Yeah. Well, imagine if I just died. It's on video. Hey, if ever that does happen, my last will and testament is just post it. Okay. Okay. Here I have, obviously, the moon. I just got this moon in my bail box. I don't think. Actually, I don't. This actually might be. This actually might be a really, really close in scale. I don't know, but if it was, this would have to be. Just so you know, the word scale means it's one of our CCCs: scale, proportion, and quantity. The orange one with the element. The scale means how big it is compared to other things. And so if this were the size of the Earth, these continents would be about correctly sized. I'm positing to you, I think even this moon might be approximately correctly sized, but I would have to be probably 50 yards away, maybe even more. I would have to look it up to know exactly, but I have to be far, far, far away. If trying to remember the diameter of planet Earth. I don't actually know, and I don't want to say because I'll be wrong. So anyway, let's just, for the sake of our model, another way this model is imperfect. One, the moon is not made of rubber branded Abaha, yeah. Other brands are available and full of air. So that's a way our model is imperfect. Another way is that, hey, an important way this model is inaccurate or imperfect is that this should be a lot farther away. So recognize that. But check it out. When I am doing this, you should be drawing the pictures. Okay, I meant to actually do both, but I don't want to both hold the ball and draw the picture. So I'm going to do like that. No, not going to happen. So this is a day or a night. Nope. No one else will appear in this video besides me. So a day and a night is like this. So that's an example. As I showed the day and night cycle with my puffed up Earth, you should draw it in your notebook, however you best draw it. I think that'll be a really good exercise for you to do something on your own for once. Also, I'll give you a second while you do that, while you catch up. And in the meantime, I'll just practice my dribbling. Something I'm obviously very good at. Basketball star. I don't actually know how to do this at all. Do use my palm or don't use my palm? Oh, I did not know that. That's great. Okay, so the lunar cycle, which is where we get the idea of months, although there's imperfections with that I'm going to talk about. I'm going to get up on a soapbox and talk about. But the lunar cycle comes from as you probably know, the moon more or less orbits the Earth. So it goes like this. Like this. But I'm going to show you something in a second here that will hopefully be new information to you. But it's not really that the moon orbits the Earth. This should be new information too. But both of them orbit each other. So as the moon's over here, they have mutual gravity, which means they both attract each other. You remember that from the first module we do, that everything attracts everything else. It's not that big Earth attracts the little moon and attracts little old you. The Earth and the moon attract each other, and you attract the Earth too. Remember, everything with mass attracts everything else. And so actually, when the moon's over here, the Earth is pulled a little bit towards the moon, and then as the moon moves, the Earth moves too. And so they both end up orbiting what's called in astronomy is called the barycenter. You don't necessarily need to know that, but it's the gravitational center between them. And I think for the Earth-Moon system, it's actually within the Earth, but it would appear that the Earth wobbles because of that. So since the moon is gravitationally unbalancing the Earth, we would see them, depending on where the moon is, as a wobble in the Earth. You might even indicate that. Let's actually do that. From the top, this little X here might be what we call the barycenter. So the Earth and the moon actually both orbit around this barycenter. And so it would be mostly the moon moving, but the Earth moves with it too. And that's also what gives us your lab. Tides. The tides. The fact that this side of the Earth is attracted to the moon more strongly causes what's called a tidal bulge there. And that means that the waters, not just the waters, but it's more noticeable with the waters, the Earth is pulled a little bit in that direction. It's not anywhere near this pronounced, but that's just to show it in the diagram. So back to the months of the year, still the sun is over there. Okay, so the sun is still the sun. In this model, the only perfect thing is that the sun is the sun. So, stop sitting for a second. Refresh your memory. Where is it daytime right now? Give me the name of a city in which it's daytime on this planet.
Right now, somewhere in America.
Yeah, I mean the sun is rising. I don't actually know if this is the way the Earth rotates. Probably should figure that out. But the sun is rising on Mexico right now, so which is not a city. Mexico City is a city. Okay, so now it's nighttime here in Africa. I'm looking right at Africa. It's nighttime, and the moon. If the moon is here, which it is, what phase of the moon will show on Africa? So the side that's getting the night can see the moon in this case, and right now it will be no. Come on, look at it. Full. The sun is shining fully on this. And so this is the drawing I would draw, even though I just told you I'm not going to draw these drawings, but I guess I will. Sun, Earth. If the moon is here, that is the full moon. So check it out. If it's nighttime where you are, you can see this moon. And if the sun is shining fully on it, you see a full moon. Doot, 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 doot. That's one of the moon phases. Now, what if instead it's here? So night is still here. What if the moon's right here? What would you see? Not a sliver, a half moon. What we call the half moon. So from the night side, doot, 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 you would see a half moon. And also, by the way, on the other side, it would be the same way. What about on this side? You would see the moon in the daytime, but you wouldn't really see the moon. You would just see, the new moon. So if it was over here, where the moon is in between the sun and the earth, you would see the new moon. And then what about these ones? What would those be probably? Crescents and gibbous. So it would be, so they're all going to, I hope you're seeing a pattern about how I'm shading these in. But from Earth, it would, excellent question, Chloe, we're getting there. That's the other thing I hope was going to, as it were, blow your mind. But and this little, I'm going to draw a little diagram here. The full moon looks like that from the night side of Earth. This would be, let's see, a waning crescent. Nope, waning gibbous. And then we would see the waning half moon. And then we would see the waning crescent. Sorry, I'm trying to draw these good, and I'm actually not good at it. And then we would see the new moon. And then we would see the waxing crescent. Waxing means getting bigger.
That's interesting.
That's interesting. It is. Yep. Did you know that words can have other meanings besides only one? Wow, I didn't realize that was going to blow your mind, but apparently it does. And then I ran out of room, but the next one would be the waxing gibbous, and then we'd have the full moon again. It would loop back to the full moon. Okay, now, 3 more things about this one. One thing I think is super cool. The first one, though, is Chloe's question. Ask your question again.
Does the moon rotate?
Yeah, it does. I wish I had a Sharpie. Does anyone have a Sharpie just offhand?
I do.
Of course you do.
Wow, I know.
I'm so proud of you, though. I'm actually maybe not so much proud as relieved because I didn't want to have to go to my desk and get one. One Sharpie, please. There's hey, Caden, right behind you, there's a green, oh, thank you. Okay, so I'm going to draw the man in the moon on this abaya. But I could probably just use this logo, but I want to draw it anyway, so. Do you see? Do you see it? I'm trying to make the camera see it too. I drew a face, but if you can't see it on the camera or in real life, you can also pretend the Bahaya logo is that. So you might know that the same side of the moon always seems to face Earth at nighttime, and that's because, so watch as I go around, if we make that be the case, you see, okay, so the same side's always facing the Earth, which is true. I'm having to kind of move it a little bit, but the same side's always facing the Earth, but did you notice that the moon did one rotation? It had to, right? If I keep this locked so it's always facing the moon, it has to rotate also. Like if we think about, as compared to the plane of the floor, the moon has done a rotation too.
No, I meant this is spin like this.
Yeah, it does. That's what I mean. It's doing this. As I go around, it has to do one of those. So one revolution of the moon is also one rotation of the moon. When those two things are the same, when an object's revolution and rotation are the same, that's called tidally locked. It means that it's fixed in with the cycle of the planet, in this case, or the body it's orbiting, the celestial body it's orbiting. So that's the first thing that I hope you find is interesting. The moon does rotate, but it rotates. Let me tell you this way, Chloe. If it didn't rotate, it would just be like this, right? Do you see how at this point we would not be looking at the same face of the moon? If the moon was not rotating at all, one revolution it would look at a different side. So the fact that it rotates, it means that the same side is always facing us. Okay, the next thing is that this process, the moon orbiting around the planet, Earth, takes 28 days. But a month, except for this month, coincidentally, is not 28 days usually. That means at least 28 days. But someone messed up. I'm gonna throw that out there right now. Maybe someone's in history messed up. If we had 28 days, if we had 13 months, which is how many times the moon goes around, what is this number? What's 28 times 13 real quick? You're right, 364. Excellent job. And how does that relate? How does that relate to the next one? It's almost exactly the same. And so if we had 13 months, which we don't, but if we did, it would very, very, very neatly line up with the moon phases. It would be not only, if I was ever going to run for political office, which I won't, but if I was, this would be it. It would be always the same day of the week, because 28, you'll recognize, is also divisible by 7. And so the same day of the week, a month would always start on a Monday. The first of the month would be a Monday, the 8th would be a Monday, the 15th would be a Monday, etc. Every day, like we wouldn't be like, oh, February 28th, what day is that? It's Thursday. We just know, because every day would be the same day of the week in every single month, because this is divisible by 7. And the real good one is that, well, we get a new month, and we could name it after Trey Gibbons. And though this is one too few days, and so everyone would just get, it would be, you'd have to arbitrarily choose, but maybe New Year's Day would just be everyone in the world takes that day off, and you don't ever have to, it doesn't even have a day of the week. I think this is really neat math, and someone should have thought about this back when they were naming months in Roman times, but they didn't. So anyway, that brings us to the seasons in the year. And so the main misconception in this, maybe this whole unit, is that people think, I'm going to tell you, now be careful because I'm telling you what people think that's wrong, and so I don't want you to think that it's wrong. Many people, very smart people, get this wrong. People think that because the Earth circles in a non-circular orbit around the sun, that the farther away we are, the more winter it is, and the closer we are, the more summer is. But that's not true. That's just not true. It's not like a campfire where the closer you get, the warmer it is. It's actually because of what did you find in your lab? I think you guys did this one. And also as you in that back group, what did you find in your lab makes it so that actually the seasons exist? The what?
The sunlight. Sunlight.
Yes, the amount of sunlight per unit of area. Why though? Because of Earth's? No, kind of. It's the tilt. It's the Earth. This is extremely important. The tilt of planet Earth. The tilt of planet Earth is 23.5 degrees off of the standard y-axis. It's just not a very good drawing is why the Earth is so oval. So the Earth is tilted at 23.5 degrees, and because of that, if we have the sunshine over here, I've drawn another sun over here. This is the equator. So even though day and night still happens, look, just like before, day and night still happens. I'm doing it at super speed though. Day and night still happens. You can see that even though day and night happens, if I have the sun there, this, where it's daytime, is the northern hemisphere. So almost perpendicular to the surface of the sun, I'm having a hard time holding it and pointing, almost perpendicular to the surface of the sun is North America and Northern Asia and Europe, right? Those places at this time would be experiencing summer. Because even though the Earth is rotating day and night, the side that is tilted toward the sun is experiencing more direct sunlight. So it's the opposite of how I've drawn this picture. So in this picture, I have the southern hemisphere is experiencing more daily sunlight. And so what season is it isn't in the southern hemisphere? Summer. And if it's summer in the southern hemisphere, what season is it where this light is hitting obliquely? That means at an angle, at a sharp angle. Winter. Winter. You'll even notice this when it's wintertime. What this looks like from Earth's surface is that the sun seems to be, as we would say, lower in the sky. It never gets up as high. You might notice that on the north side of your house, I was going to say your backyard. My backyard is on the north side of my house. But in the north side of your house, you might find that earlier in the year especially, but even this time of year, there's a little patch of snow that won't melt because the sunlight's not high enough. Whereas in the summertime, the sun might even come directly down on that spot because the sun is, we see, higher in the sky. But in the celestial pattern is that it's facing the sun in the summer, and it's facing only obliquely, only at an angle towards the sun in the winter. So what about fall and spring then? What's true of fall and spring?
It's the same. Isn't it like the same amount of sunlight in fall?
Yeah,
Just in between the two.
Yeah, it's roughly similar in the northern and the southern hemisphere.
And it's like even more than I just did?
Yeah, more or less even. In fact, the celestial special date in spring and autumn is the equinox, which is where the day and the night are the same length. And in the summer and the winter, it is the solstice, where the longest night is in the winter and the longest day is in the summer. You might remember those days. Okay, and then the last thing kind of relates to all of them, and it is that I need to get, I should have done this while I still had my moon and while I still had my Earth up. But, thanks, Teague. We don't throw things. Sometimes, kind of rarely, but sometimes it lines up just so, I want to do this on the camera too. Sometimes it lines up just so that a shadow, you can kind of see maybe a shadow. Yeah, it's going to be an eclipse. Sometimes it lines up that a shadow from the moon is cast on the Earth. You should write this down. Shadow on the moon cast on the Earth is called a solar eclipse. We name it after what's being eclipsed. What has something go in front of it? So, yeah, in this case it's the sun. The sun has the moon go in front of it, so we call that a solar eclipse. You've seen one. Do you guys remember seeing the solar eclipse?
Yeah.
You were like, okay, but you were a human being when you were 7, roughly. You should remember that. And then if it's the other way around, I'm going to have to switch hands. If it's the other way around and the Earth's shadow is cast on the moon, that's a lunar eclipse because the moon is what's being eclipsed. Of course, we say both of those things from the standpoint of planet Earth. And so the moon's being eclipsed by the Earth in this case. In the other case, the sun was being eclipsed by the moon. Do you know what a lunar eclipse looks like? Usually it looks red because it's changed. The shorter wavelengths, the blue and purple and green light, is being absorbed more easily by the atmosphere, and so the moon appears to be red. But at the height of a true lunar eclipse, it might even look dark, like just black. Yeah, you play too much Zelda, probably. But the solar eclipse was a whole different thing. And actually, hey, I'll leave you with this. I'm just going to go sit down after this, but you guys can work on your explorations. But I'll leave you with this. It is a celestial absolute miracle that this can happen, because it just so happens, it would not have to be this way, but in the sky, what we call the angular size of the Earth, the moon and the sun are almost exactly the same. The sun is about 40 times larger in diameter. It might be 400. It's some number of times larger in diameter, but it's also that exact same number as far away. And so the moon's a lot smaller. But it's way closer. And so it just so happens, a celestial miracle, that they seem to be the same size in the sky, so the moon can exactly eclipse the sun. This is the only planet in our solar system and that we know of anywhere where that is true. So isn't that kind of sick? It is.
Wow.
Bye.